Welcome back. We're on lesson 7.3, similar triangles. We just finished talking about similar polygons, so now we're going to take it a step further and just focus on triangles. There are three important theorems that kind of go along with proving two triangles are congruent. Now these are a little bit different, so you can focus on page 478 where all three of these are listed. But we're going to go through them here on our notes. Again, three colors for today. We're going to highlight certain parts on our triangles to prove these different theorems. So, first one is called the angle-angle. This one is where you have only angles, no sides, but it says that if two angles on one triangle are congruent to two triangles on another, then the triangles are similar. It doesn't mean that they are congruent. Remember, all of these theorems are just proving similarity. They're not proving congruence. So what this means is, let's say angle A here is congruent to angle D on the other triangle. And let's say that angle B is congruent to angle E. So if we have two angles that are congruent, then we can say that these triangles are similar. So let's write that out. If angle A is congruent to angle D, and, very important, two angles, angle B is congruent to angle E, because we have two congruent angles, we can say that these triangles are similar. So then, triangle ABC is similar to, so that funny little squiggly, to triangle DEF. That's angle-angle similarity. The second theorem is side-side-side. Now this is not the same as side-side-side congruence. This is proving that these sides are proportional, not necessarily congruent. So what it's saying is if our sides are proportional, then the triangles are similar. So if AB is proportional to DE, and let's say that ratio is proportional to BC and EF. Okay, now that's two sides. Remember, we have side, 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 so we need all three sides to be proportional to each other. So we have AC and DF. If that is true, then we can say our triangles are proportional. Triangle ABC is similar to triangle DEF if all three sides are proportional. If two sides are proportional, are they similar? Not necessarily. All three have to be proportional for them to be similar. The last one is side angle side. Again, this one is not proving that they are congruent. It's proving that they are similar. So you have a side, AB. Let's say its corresponding side is DE. You have an angle in between. Let's do angle B and angle E. Those two are right angles. And then you have another side, the side on the other side of the angle, if we have side angle side, in other words, if angle B is congruent to angle E, and, so only one angle, AB over DE, these two corresponding sides are proportional to BC and EF. If that is true, then triangle ABC is similar to triangle DEF. Okay? We're going to use these three theorems in this lesson to not only prove that triangles are similar, but to be able to solve different triangles. So, example 1, we want to decide whether or not these triangles are similar. If so, write a similarity statement. So, I don't see any side lengths. So, are we going to use side, side, side? Probably not. Are we going to use angle, angle? Yes. So, what I see is angle B is congruent to angle D. Now, I need two angles, though, to prove that these are similar. I know angle B is congruent to angle D, but these two are different. So maybe one of these missing angles can match up. So let's solve for A. Angle A, we're going to take 180 and subtract it from the sum of the other two angles. So angle A is going to equal 80 degrees. Hey, that works out because angle A is 80 and so is angle E. Angle A is congruent to angle E. So I have two angles. So by AA similarity, these two triangles are similar. Now you need to be careful how you list the letters. I'm going to go in order here. A, B, C. Now I may or may not go in order here. This triangle, I started with angle A, the pink angle. The angle that corresponds to that is angle E. So ABC is similar to EDF. The order matters. And it is by AA, angle, angle, similarity. Okay? Alright, example number 2. Let's look at this one. Okay, right away, I see that I've got vertical angles right here. Okay, so this is angle QXP, and it is congruent to angle NXM, because they're vertical. And because these two lines are parallel, that means this angle up here, angle Q, it's congruent to this angle down here, angle M, or N. Angle Q is congruent to angle N because they are alternate interior angles. I have two angle groups that are congruent, so that means that these two triangles are similar. Triangle QXP is similar to triangle NXM by AA similarity. Awesome. Let's try the next page. Example number 3. I I need to decide whether these triangles are similar. So same kind of thing, but now I don't have any angles. So I'm going to be using either side, 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 or side, angle, side. Since letter A has no angles, I'm going to be looking at their sides, seeing if they are proportional. So I've got this side right here, AB. Its corresponding side is over here, DE. So let's set that up. 9/6. Let's see if that's proportional to this side right here, AC, which corresponds to DC. Let's see if that, are those proportional? 9 times 4 is 36. 6 times 6 is 36. Okay, those are proportional. We need to see if this ratio of 9 and 6, if it is proportional with the third side. Right here, 7.5 and 5. Nine times 5 is 45. 6 times 7.5 is also 45. Okay, those are proportional. So, this is similar. Triangle ABC is similar to triangle. Now remember, order matters. I went from the orange and green down to orange and pink. So D, E, C. And it is by side, side, side similarity. Okay, letter B. I also see sides, but I don't see any angles, and I don't see any measurements here. So, I can't use side, side, side because there's no measurements here, and I cannot assume that they are a ratio because there are no measurements. So, I need to maybe think about what else I could use. I could use angle, angle, but I don't see any angles. So that must mean I need to use side, angle, side. Now I know you're saying, well, you just said there's no angles. And I did. But I'm looking at this little triangle here, and I'm comparing it to this big triangle. Okay? They both have in common angle M. So is angle M congruent to itself? Yes, that's the reflexive property. So I need now two sides to make a ratio. So let's look at this. I've got this side here on this pink triangle, 10, and it corresponds to this long side, this whole side. So I have to think about how long is that side. That side is 25. So 10 over 25. Is it proportional to these lengths? 12. And then how long is this whole side over here? It's 30. Are those proportional? Does 300 equal 300? Yep. So we can say triangle MNP is similar to triangle MRS. And what's our reason? Side, angle, side. Excellent. Let's do our last one, and it's multiple choice. Okay, we know that we have two triangles, And we know that RS is 2 and XY is 3. That's their ratio. Which of the following would be sufficient to prove that the triangles are similar? Think about our 3 theorems. For angle, we need 2 angles. I have a ratio of one side, and, oh, there's one angle pair. That doesn't work. Let's think about side, side, side. So I need 3 ratios. That only has 2. That only has 2. Not going to work. So, hey, letter B is our answer choice. Okay, tune in next time for lesson 7-4.